All right. Today we're going to move on to the chapter 16, ratios and percents. Okay, and we're going to very, very quickly talk about ratios, lesson 1 and lesson 2. But then we're going to focus primarily on lesson 3. Because lesson 1 and lesson 2 should not be difficult for you. What? Oh, yeah.
So it's lesson 2?
16. Go to lesson 1 first. Because I want to make sure that we touch on it. But it should not be very difficult for you. Okay? When you look across the top of page 396 and 397, you see the word ratio. Tell me what a ratio is. JT?
A comparison where for every X units of one quantity, there are Y units of another quantity.
Okay, so if I had a marker that worked, this would work better. So we could do, here's a purple dot, a purple dot, a purple dot, a blue 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 dot. Okay? So, how could I take this and write a ratio? There are 3 purple dots for every 6 blue dots, right? There's my ratio. Okay? These 2 dots tell me that I'm dealing with a ratio. Okay? Ratios are kind of like fractions in the sense of there's equivalent ratios just like there's equivalent fractions. If this was written as a fraction, 3 over 6, what would this reduce to? 1/2. Let's think about that. What they're telling us here is I have half the number of purple that I do blue, right? So I could also say this ratio is 1 to 2. For every 1 purple, there are 2 blues. 1 purple, 2 blues. 1 purple, 2 blues. Notice I still have 3 purple, I still have 6 blues. Okay? So ratios can be broken down or in essence reduced just like fractions can be reduced, okay? Not new, right? We know this, I hope. If you don't, you need to make sure you see me and I will be glad to go over it with you. Okay? So very quickly, let's look at our book at number 1. On page 396, it says circles to squares. Tell me the ratio on your board. Give me 2 ways I could write the ratio for circles to squares. Circles to squares. Reduce 2 to 4. How would I reduce that? But write it as a ratio. No, go ahead and write it. I could write it 1 to 2, yes, or I could write it 2 to 4. Very good. Alright, so my question for you, if I have a ratio that's written as 6 over 9, please understand when we're talking about ratios, I can also write that in fraction form. For every 6 triangles, I have 9 squares. Typically, we will see ratios written with that symbol between my numbers, but fraction form is not incorrect. Okay? So if I have a ratio that says 6 to 9, tell me two other ratios that could be equivalent to this. Luke? 1/3. What else? Not 3/5. Not 3/6.
12/18.
12/18 would also work. All I did is multiply this number times 2 and this number times 2. So it could be 12/18.
609.
Yes, that would be 2/3. Not 1/3. Sorry, I wasn't looking. Okay, so 2/3 would work. 12/18 would work. When I got 2/3, all I did is divide 6 by 3 and 9 by 3, right? Okay, so I can make equivalent ratios by making them smaller or reducing them. Or I can make equivalent ratios by whatever I multiply one number by, I multiply the other number by. So I could say 6 times 3 is 18. 9 times 3 is, this would be another equivalent ratio to 6 to 9. Okay? Just like fractions. You can make that fraction bigger, you can make that ratio bigger, or you can reduce it and make it smaller. Clear? Good. If not, please see me. Hop to lesson 2. All right. When I see the word percent, that means out of 100. Okay? Every percent is out of 100. Or percent itself means out of 100. Okay? So they're giving us, and to save some time instead of me drawing it, look in your book on page 398 and 399. If I have number 1, it gives you a pink hundredth block, and some of them are shaded and some of them are not. Tell me how many are shaded. 37 to 100, which is 37 over 100, 37%. Okay? Let's look at another one. Look at the second one. 75 of the 100 are shaded, right? Okay, so I can write that as 75 out of 100. Anything over 100, I can turn that into a percent by writing it with the percent sign. Essentially, folks, what I did, well, we'll talk about that here when we talk about turning them from decimals to percents. Okay? So percent means out of 100. 75% out of 100 of these are shaded. Okay? That's not new either, right? Okay? So if I give you something like 9 over 100, you can tell me what percent that is, right? 9%, right? Okay? If I give you something that looks like, can you write that as a percent? 35%. Okay? So it does not matter if I write it in ratio form, fraction form, okay? As long as you realize, or I could write it as words, 75 to 100. Either of those I can convert into a percent. Okay? flip to lesson 16-3. Alright, now we're going to work on converting back and forth. So I had, in one of the days that I was out last week, I had them do with you a sheet where you were practicing turning a fraction into a decimal and a decimal into a fraction. Do you remember that?
Yeah.
Okay, so if I'm given a fraction that looks like 2/4, okay, I can turn this fraction into a decimal. How do I do that? How do I turn a fraction to a decimal? Kaden? Absolutely. 2 divided by 4. Then what do I do? Luke? Decimal point behind the 2, because 4 doesn't go into 2, right?
Nope.
Okay. So add my decimal point and a 0. Then what's my next step, Jeffrey?
The next step is to do 4 divided by 2.
Nope. Paul?
Take the decimal and put it.
Yes, put that decimal straight up in your answer so you do not forget it. That will be your biggest mistake. Okay? Now what can I do? Kirsten?
4 times 1 is 20.
4 times what equals 20? I'm no longer looking at this as 2. I'm now looking at it as 20. 4 times what gives me 20?
5.
5 times 4 is
20.
0. Since I have a 0, do I need to bring anything else down? No. The only time I would have to add another 0 is if I had a remainder. Okay, I cannot have a remainder when I'm dealing with decimals. So, 0.5, my number sense tells me I can write 0.5 as 0.5 or 0.50. Either one's the same, right? Because I can add as many zeros to the end of this number as I want, and it does not change it. Okay? 0.5000, same thing. So, when I look at 0.5 and 0.50, who thinks they can tell me what percent that is? Ella, what do you think? 50%. Explain to me how you knew that.
Because a percent is out of 100, and you can't do like 5. Like you can't do it's in the percent it's on the 10th place, so you have to have that zero to make it on the 100th place, and then that is 50%.
But how do I know that I can go from 0.50 and that means 50%? What am I doing essentially?
You're multiplying
Not 10.
You're adding. Well, you're
Remember, percent means out of 100, so I'm not multiplying by 10, I'm multiplying by percent means out of 100.
Oh.
So what am I multiplying by?
100.
100. Okay, so let's think about this, folks, very quickly. I'm going to run out of time here. If I have 0.50 and I want to multiply that times 100, okay, I can do all this math if I want to, but 0, 0, placeholder 0. 0, 0, I need 2 placeholder zeros. Okay, 1 times 0, 1 times 5. Okay, then I could add all those together. Now, multiplication of decimals says count your decimal spots, put them in the answer. Then I would get 50.00, which is the same as 50, add your percent sign. Okay, so when you go from a decimal to a percent, all you're doing is multiplying that decimal by 100. Okay, to get from that decimal to that percent. So what we're going to do today, we're going to practice this, going from decimal, percent, and fraction. And what I'm going to do is I'm going to give